It is common that businesses may encounter the presence of limiting factors or resources that is scarce in supply at all times. It is therefore important for the businesses to seek solution on it. One of the solutions is perhaps to pay for additional supply on such resource. So here comes the golden questions. How much should the businesses be paying for such limiting factor? And these therefore give rise to the needs to determine and estimate the value of shadow price. Hello, my name is Tze Kang, the expert tutor for performance management. This topic explainer is on shadow prices and other limiting factors. This part of the video on shadow price and other limiting factors will be mainly referring to ranges of ACCA resources, primarily study hub. For learning purpose, you are advised to spend time on chapter 6, in particular on shadow prices and other limiting factors. As you may see, there are three main sections on this chapter 6 on shadow prices, which I will classify into type 1 for the first and the third sections on shadow prices, and finally type 2 of the decision on the shadow prices pertaining to make or buy. Apart from learning, you are advised to spend time on practicing the exercises on the relevant subject matter, quizzes, as well as practices, which are all comprising of ranges of questions for especially objective test questions for your familiarizations on the subject matter. And followed by, for recapping the knowledge, you are advised to spend time to look at the flashcards to get yourself familiarized with the terminology and a quick snapshot on explanations for the terms. Last but not least, ranges of technical article. In particular, for this topic explainer, the topic on linear programming were found in one of the articles that you are highly recommended to spend time on it. And not to mention about practice platform and examiner report, they are all essential to assist in leading to your exam success. Let's first go through what exactly is shadow priced, what gives rise to shadow price, followed by the way to derive and estimate the value of shadow prices, and finally, knowing the value of shadow price, what can the businesses to do with it? And all these explanations were then accompanied by demonstrations on ranges of activities and example which are found in the study hub. So what exactly is shadow prices? And the answer is, it is representing by the changes in the payoff. In particular, the increase in the payoff that measured by contribution should one additional unit of such limiting factor is made available to the businesses. That gives rise to the incremental in the contribution. When exactly shadow prices may arise? And the answer is, it will arise in the business where the activity will get restricted by the limited in supply on at least one or more than one type of resource, which is termed limiting factors, resources that is scarce in supply, or alternatively, it may be termed bottleneck resource. Guys, it is worth for you to take note on the reverse or the contrary of limiting factors of the resource. It is equally common that businesses may experience resources whereby the availability of it is in excess to the requirement of it. So that is the contrary to the scarce resource. Such spare resources that give rise to unused resource is termed the slack. This is mainly for learning purpose. So, how do you exactly to derive and estimate the value of shadow prices? To me, that's very much depending on what exactly are the type of decisions you're experiencing. As mentioned a moment ago, there are two main types of the decision. The first one is mainly asking to prioritize the productions on ranges of products based upon the common type of limiting factor. So with this kind of scenario, the first circumstances that give rise to shadow prices is where there is only one or single limiting factor that is present? Well, as you may learn in other part of the sessions, in these kind of circumstances, you may be required to come out and determine the priority, the sequence order in allocating the limiting factor based upon the contribution per limiting factor for each and every types of finished goods or products. And then we rank the allocations on limiting factor based upon the sequence of such contribution per limiting factor. However, should circumstances arise whereby by allocating all the available limiting factors, there are still unfulfilled demands on certain products. So that is when shadow price comes into pictures. As explained a moment ago, the value of shadow price is hence reflected by the contribution per limiting factors on those products that come with the highest contribution per limiting factors among those products that is still containing unfulfilled demand or unsatisfied demand. That is exactly how the value of shadow price is determined for single limiting factor. So here's the second scenarios on type 1 decisions where there is more than one limiting factors that present. So guys, based upon what you may have learned in the earlier study, linear programming techniques may be used in solving such a multiple limiting factors problem by deriving optimal production plans for most commonly two unknowns, which representing the production quantity on two finished goods of a company. Based upon such optimal production plan that you should have learned in linear programming technique, which is not part of this video to demonstrate the process in full, you will therefore be able to make use of the optimal production plan in deriving the resulting payoff, which is termed contributions based upon the above answer. And that will be the end result if the question is not requiring the estimations of the value of shadow prices. However, should estimations of shadow prices required, you may need to take the step further by reapplying linear programming technique in step 3 based upon the situations where availability of such specific limiting factor has now increased by one additional unit. With these revised constraints, you will then derive the revised optimal production plan for the two unknown again. Given the additional supply on the limiting factor, it is likely that the revised optimal production plan will be larger or higher than the earlier results. With these revised answer, you will then derive the resulting payoff, which measure by again contribution based upon the earlier step of the solution. With the two set of contributions derived, the first one that's derived from step 2 before increments in limiting factor as comparing to the contribution on the revised optimal production plan with the increment of 1 unit on limiting factor, it is likely that the latter, the revised contributions on the revised optimal plan will be higher than the earlier one. The difference represents the incremental in the contribution, that representing the value of shadow price. So guys, with both types of shadow prices calculation, one with single limiting factor, second involving with multiple limiting factor, what's the purpose of these value of shadow price that derive as asked a moment ago? Well, the value of shadow price will then help the business to determine and estimate maximum price that we are worth paying to obtain one additional unit of such limiting factor. How exactly this maximum price is set? And the answer is based upon original cost price of such limiting factor, termed as Y, and then we are afford to pay additional premium representing by the buffer that is measured by shadow price, termed as Z. The total of both values will therefore give rise to the maximum cost that is worth paying to obtain one additional supply of such limiting factor. So it's time for you to take a look at the following demonstrations on both scenarios on type 1 decision. Let's start with how to deal with shadow price calculations under single limiting factor. With these following activity and exercises, which is all extracted from Study Hub, looking at the first activity, you are asked to estimate the maximum contributions that could be achieved with the restriction on material R up to 12,000 kilo to produce the three products H, I, and J. Guys, spend some time, pause the video, take a look at the information, and give a try to derive the answers for a better understanding. Same thing applied for all the exercises in this part of the video. So with these informations provided, we will also be given contributions per unit for this product and consumption of material R. To allocate these limiting factor, we would need to rank the priority of this product based upon contribution per limiting factor. By dividing both the values, as mentioned a moment ago, you will be able to come up with contributions per kilo of R. With these, that will allow you to do the ranking accordingly. So guys, in the absence of any restrictions on demand for the products, all the 12,000 kilo of R that is available, should they fall, allocate in making just one product, namely I, that generate the highest contributions per limiting factor. So this will allow the output of I going up to 6,000 units, and with these, that will generate a maximum contributions up to $60,000. Well, with these situations, once it gets a little more complex, which explained and denoted by activity 2, what if product I has a restriction on maximum demand up to 4,000 units? Then I'm afraid there is no point to produce up to 6,000. We need to come up with a table to start allocating the limiting factor based upon not only the limitations on R, but also restrictions on the demand. With the 12,000 kilo, there is no doubt to first allocate to I to fulfill up to the maximum demand of 4,000. And that requires 8,000 kilo of R, and that will leave 4,000 kilo of R remain unused. With all the remaining 4,000 kilo, we should then allocate to the second profitable product, namely H. By making use of all the available material R, that allows the production of up to 1,000 units of H. Taking note that H, however, is still not subject to any restrictions of demand, so therefore we will be able to make and expect to sell all the 1,000 units of H. With this output, multiplying with the contributions per unit, and the resulting contributions will give rise to the total of maximum contribution as such, with the presence of restrictions of demand for I. Well guys, here comes the golden questions. What exactly is the value of shadow price for R if R is to make available with one additional kilo? Given that the demand of H, it still remains unlimited. So with one additional kilo of R, it is likely that it's worth spending to produce additional unit of H, which is called as unfulfilled products. Well, these would therefore give rise to an additional contributions per kilo of R of $4. That increase in the contributions from that scarce resource in H is therefore explain the value of shadow price of R in these circumstances. So guys, after looking at a rather simple exercises involving single limiting factor, it's time to take a look at the second scenario where it involves multiple limiting factors. Again, spend some time, pause the video, take a look at the information and give a try on the requirement for this activity. Well, firstly, you are asked to formulate the scarce resource issues experiencing by this company under linear programming model. So with these informations above, you would be able to come up with these formulations of the constraints. With these constraints formulated, part B would have provided the following diagram that depict all the constraints correctly, and then you are asked to determine the optimal production plans for the furniture, and finally, to determine the resulting maximum contribution. By making use of this diagram that is clearly showing the dotted line representing the ISO contribution or objective function line, and moving within the feasible region depicted by the bolded line, the last point that this objective function line touches at last when it moves outside the region is clearly touching at point C. That is the last point it touches. By making use of simultaneous equations approach, you should be able to derive the coordinates of both the products, and that happen to come to 20 units for each of the products. With the resulting combinations of these outputs applying into objective functions of deriving the contribution that determine the maximum contribution in the event when all the limiting factor is as per what explained by the questions. So again, guys, here comes the golden questions. What exactly is the value of shadow price if this time the shadow price is referring to the unskilled label as mentioned by the questions? So therefore, applying the step as explained a moment ago, we will need to extend the linear programming model a step further by modifying the availability of these constraints, adding with 1 unit of unskilled label. And with this revision, that will therefore depict a revised diagram as below, particularly the positions on unskilled label function with a little bit outwards moved towards the outer region. As such, that would enlarge the size of the feasible region marginally. Well, with the remaining lines remain unchanged, particularly the ISO contribution or objective function line, but moving outwards, the last point it touches is still point C. By using simultaneous equation that derive the coordinates of point C representing the output of X and Y. As expected, the output is clearly larger than the earlier solutions before the revisions on the supply on the unskilled label. Once again, applying to the objective function that allows the derivations on the revised contribution that is expected to be greater than the original one. The incremental in the contributions that comes to $6.65 is therefore representing the value of shadow price for unskilled label as such. So guys, time for you to take a look at the second type of decision that may give rise to shadow price, namely make or buy decision. Frankly, this is a decision that is an extension on limiting factor decisions that explained earlier. In this part of the decision, what the situations that give rise to the company is that with the presence of limiting factor, the company will not be able to satisfy the productions of all the products unless they obtain additional supply. In these circumstances, however, instead of obtaining additional supply of limiting factor, we are thinking of, for those unfulfilled production, are we able to outsource from external party? So now it gives rise to the questions, which of the products or which of the component that is worth making internally, which of it is worth buying externally. That gives rise to make or buy decision when there is a presence of limiting factor. The step to overcome this decision is to starting with, firstly, to make up a mind which of the component or product that is worth making or worth buying. And to answer these questions, we need to come up with the relevant cost for each of the alternative and make a comparison. Finally, choose whichever that is the cheapest of obtaining the component or obtaining the products. That gives rise to the decision which to make and which one to buy, on the assumption there is no limiting factors that is existed. However, when there is a presence of limiting factor, it will affect particularly those products that is worth making because it is cheaper comparing to buying. With the presence of limiting factor, those products that is worth making may not be able to fully satisfy with the limitations and the factor. So therefore, in step 2, those product or component that are recommended to make will need to derive with the saving per limiting factor as such. So how do we derive this value? By comparing the two of the relevant costs. If the relevant cost of buying is more costly than making, obviously the difference represents the savings if the product is to make internally. By converting the saving per unit into per limiting factor, by dividing the saving per unit with limiting factor per unit, that allows the derivation of savings per limiting factor denoted by S. What do we do with this value? And the answer is we will now start ranking the component or the products based upon the value of S, commencing with the highest S as a start. With this ranking, we will then be able to allocate the limiting factor to those products that is most worth to make internally. However, this is the answer if the question is not going a further step asking for shadow prices. So what if the question asks for shadow price calculation? You may then have to take a further step, number 5, by looking at the shadow price based upon the saving per limiting factor on those component or product that come with the highest value of the S among those items that are unable to make due to limiting factor. So this is how shadow price is determined based on make or buy situation. Guys, before looking at the demonstration, it is worth to take note. Once the shadow price is derived, the purpose of knowing the shadow price is still the same as above. It allows the businesses to estimate the maximum price that is worth paying to obtain such limiting factors. Here comes the last type of the exercise and demonstrations for type 2 decision. Spend some time, pause the video, give a try on these questions before listening to the rest of the part of the video. This activity is asked to determine which of the product or components that is worth making or which one worth buying. After going through the information, you will notice relevant cost of making versus relevant cost of buying reveal the fact of the 3 products that is required to be made by the company. All seems to be cheaper in making comparing to buying, mainly because relevant cost of making are all lower than relevant cost of buying. However, this isn't the answer if it comes with the presence of limiting factor. Particularly, they said the supply on one of the resource, material B, is limited to 8,000 kilo. Is that a problem? What you have to do is to take a look at the units required, multiply the consumptions on the material B. You will notice the requirement on B is way more than 8,000. So in the presence of this limiting factor, you may need to rank to allocate the limiting factor based on the saving per unit of limiting factor. So as such, from this saving, that tells us, given the choice, we should allocate material B to make Y, followed by Z, lastly X. So with this ranking, we would then be able to come up with a sequence of allocating material B. So as such, the output that we can make for both the product comes to as follows. The entire output required for Y of 2005 will be able to make fully. However, with the remaining part of material B, we only will be able to produce up to 3,000 units of Z, where the total demand is 4,000. So it's clearly there is an unfulfilled demand for Z due to limiting factor. So guys, here comes the golden questions. What if the company require to buy additional supply of B? What will be the shadow price? And the answer for this is still based upon, instead of contribution, we are now looking at savings per limiting factor. So from this item, The unfulfilled products is obviously product X and Z. Among the two, the one that carry the highest savings per limiting factor is obviously Z. And by allocating 1 kilo of R, the contributions which measure and replace by savings right now, it's $2 a kilo. So with the saving that is the highest up to $2 per kilo, that greatest value of saving per kilo will then represent the shadow price of B in the make or buy decision scenario. So with this demonstration, I hope you have a better idea and understanding in dealing with and unveiling the mystery of shadow price. With that, thank you for watching.